Hi, in this video I would like to discuss the solution to this circuit problem. The first question is asking to determine the values of the resistances RA, RB and RC. As you can see, we have three current sources and we have the voltages across each resistor. So in order to find the value of the resistor, remember that you need both the voltage value across the resistor and the current that is passing through that resistor. So since we have all the voltages, all what we need to find is the currents that pass through each of these resistors. So let's first consider the current resistance RA. So our focus will be on that node and see what the current goes into the node and what are the currents that leave that node. So you can see that there is a 3 ampere current entering that node, so 3 amp, and which will result of two currents going out. One, we will call it IA, and the other current is just 2 ampere. So in this case, we know that it's clear that the current IA is simply equal to 3 minus 2, and it's equal to 1 ampere. So IA is equal to 1 ampere. And the voltage VA across the resistance has the correct signs, plus and minus. Usually when the current enters a resistor, you put a plus sign at the beginning of the resistor and you put the negative sign at the end of the resistor, which means that the current is moving from a high voltage to a lower voltage here, and the voltage difference between these two nodes is simply given by 4 volt. So in this case we can easily calculate RA. So RA is equal to the voltage, which is 4, divided by the current 1, and that gives us 4 ohm. Now what about RB? For RB, let's focus on this node. There is a current going in this direction with a value of minus 1.5 ampere, and there is a current going into this direction with a value of 2 ampere. So if you add them together, 2 plus 1.5, the result of the current going this direction is given by 0.5 ampere. So 2 plus minus 1.5 is 2 minus 1.5, which is 0.5 ampere, and this is IB. So since the current is going in this direction, since we assume that the current is going from here to here, then the conventional voltage drop across the resistor must look like this, plus or minus VB. Okay? So in circuit theory, if you are given already the signs Okay, so you can always switch these signs and change the sign of the voltage. So you can interchange this with that. So this becomes minus and this becomes plus, and you change the sign here. So VB, it's clear now, VB is basically equal to 3 volt, not minus 3 volt. It's 3 volt because we switch the voltage drop signs, and then you need to switch and change the voltage sign. So in this case, VB is equal to 3 volt. So RB is equal to VB divided by IB. VB is 3 divided by 0.5 ampere, and the answer is 3 divided by a half. So what you happen is you convert the division to multiplication and you flip the fraction, or basically you take the reciprocal, you multiply by the reciprocal of half, which is 2, and the answer is 6 ohm. So RB is equal to 6 ohm. Now what about RC? So notice that at this node, the current entering this node value is 0.5 ampere. The current entering this node is 1 ampere. So if you add them up, you will have this current equal to 1.5 ampere. Because this current 1.5 ampere is going into this direction, the voltage drop across RC is the conventional one. So the voltage VC, 12 volt, is just VC. So RC in this case is simply equal to VC divided by IC. IC is just 1.5. So this is equal to 12 volt over 1.5, which is 12 volt divided by 3 over 2. So you can convert the division into multiplication and you take the reciprocal. So the answer is 24 over 3, which is equal to 8 ohm. So RC is just 8 ohm. And that concludes part A. Now what about part B? Part B, determine the value of the power supplied by each current source. So let's just redraw the circuit again. Okay. And identify the values here. So we have that RA is equal to 4 ohm, RB is equal to 6 ohm, and RC is equal to 8 ohm. And we have the current in this direction, 0.5 ampere, and the current in this direction is 1 ampere, and the current here is 1.5 ampere. So the power across the 2 ampere, the power supplied by this current source is given by, so the power of S, so let's call this source 1, and this is source 2, and this is source 3. So PS of any source, PSI of any source is just ISI, so the current leaving the current source multiplied by the voltage drop across that current source. So the first thing you do to make things easy, you need to identify your ground which is the 0 volt, or we call it the reference point. And let's call this the ground. And the ground has a voltage equal to 0. So 0 volt. Okay? In this case, if this is a 0 volt, okay, so we have to be careful about this. Remember that RC has a voltage drop of 12 volt, which means that the voltage difference between this point and that point is 12. So if one of them is 0, okay, then the other should equal to 12 volts. So this node, if you measure it with reference to 0 or with reference to the ground, it will show you 12 volt in the voltmeter, because there is a 0 here, 12 volt difference drop on RC, then this is 12. So if you go from high level to low level, 12 volt, it's delivered to RC, and then at the end there is a 0. So if this is 12 volt, and remember that the voltage difference between these two nodes is equal to 4 volt. And since the plus is here, then this node has higher voltage than 12 by 4. So this should be 16 volts. So 16 volt, and the resistor will take 4 volt, and the 12 volt remains on that node. Similarly, the voltage difference between these two nodes is minus 3 volt. So if this is 12 volt, so this means that because the difference between these two voltages is a negative, so this node must have a higher voltage than the 12 volts, so by 3, which is just equal to 15 volt. So remember, so now if you take 12 minus 15, 12 minus 15 is minus 3 volt. So now we determined all these voltages. So let's see now what's the power delivered by each source. So let's take PS1. So in this case, we have PS1 is equal to VS1, so that's VS1 multiplied by IS1, which is equal to, so PS1, the VS1 is just, so this is how we put the plus minus. So it's 15 minus 16, so the voltage difference here is 15 minus 16 multiplied by IS1, which is the current leaving the source, which is 2 ampere, and the answer will be minus 2. So it's minus 2 watt. Now what about S2? So PS2 is just VS2, the voltage drop across the voltage, the current source multiplied by IS2. And the voltage drop, as you can see, is 15 minus 0. So this is 15 minus 0, because VS2 is, according to the sign of the current, is plus minus like this. And so this is VS2, and that's IS2. Multiplied by IS2, which is minus 1.5. So the answer will be 15 times minus 3 over 2. And that's minus 45 divided by 2, which is equal to minus 22.5 watt. Now what about S3? So PS3 is equal to VS3 multiplied by IS3, and that's equal to, so the voltage drop across the source S3 is like this, and 16 minus 0, 16 minus 0, multiplied by I is 3, which is 3 ampere, and the answer will be 48 watt. So to summarize, so we have that PS1 equal to minus 2 watt, PS2 is equal to minus 22.5 watt, plus we have PS3 equal to 48 watt. So the total power delivered by the sources is PS1 plus PS2 plus PS3, and the sum is minus 2 plus minus 22.5 plus 48, and the answer is equal to 23.5 watt. Now the last question, it's asking to determine the values of the power received by each resistor. So again, it should be same procedure. So we know that from here that PA, the power received by the resistor A, is equal to the voltage across RA times the current going through A. So that will be 4 times 1 ampere. So it's 4 times 1, which is 4 watt. What about PB? So the power VB is equal, PB is VB multiplied by IB. VB is equal to 3 volt multiplied by IB, which is 0.5 ampere, and that gives me 1.5 watt. The last one, RC, to calculate PC is equal to VC multiplied by IC, which is equal to VC equal to 12 multiplied by 1.5, that will be equal to 12 times 3 over 2, and that's just equal to 16 watt. So now, if you calculate, so to summarize, so we have the power PA is 4 watt, and PB equal to 1.5 watt, PC equal to 18 watt. So the total power received, received by all the resistors must equal to the total power supplied by the sources. So what is that? PT, the total by resistors, is equal to PA plus PB plus PC, and that's equal to 4 plus 1.5 plus 18, and the sum is 23.5 watt. As we mentioned, so these two values must be equal. That's it.